So, our domain for this. We know if it's a fraction that the bottom can't be 0. So if you set x squared minus 4 equal to 0, we know that x squared cannot equal 4. So your domain, you could either tell me x cannot be plus or minus 2, or you could write it in an interval, negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. B, I asked for x and y intercepts. So the x-intercept, that's when y equals 0. So if I put in a 0 for my f of x, the first thing you would do in solving that is multiply over your denominator, and 0 times anything is 0, so you just get x equals 0 for the x-intercept. For the y-intercept, if you plug in 0 for all of your x's, you also get 0. So x and y-intercepts are both 0. C, symmetry, we plug in a negative for our x. If we get the original back, that means it's symmetric to the y-axis. If we get the exact opposite, that means it is symmetric to the origin. So if I put this in, a negative squared is positive. So is this the same as what we started with? No. Is that the exact opposite of what we started with? Yeah, it's like taking the original times negative 1. So it is the exact opposite. So this is symmetric to the origin. D, asymptotes. The vertical asymptotes are really closely related to your domain. Your domain, you're telling me what x cannot equal, so for the vertical asymptotes, you'll write this as x equals. So x equals 2, x equals negative 2. For the horizontal asymptotes, what do we have to do? The limit. I told you if you wanted to do it together, you could, as long as it's just, a polynomial over a polynomial. So we're doing the limit as we approach positive and negative infinity of our original. I will expect you to write out this limit work on the test. So if you just skip it or say it equals something, you're not going to get credit. You have to show me how you got there. I can't just plug in infinity right now. I get infinity divided by infinity, and we don't know what that means. So our trick has been to take everything and divide by the highest power of x. So I'm going to take everything times 1 over x squared. So that would give me a 1 over x over 1 minus 4 over x squared. If you have a number divided by infinity, that goes to 0. So this is 0 over 1 minus 0, which is 0. So the horizontal asymptote, y equals 0. All right. Step E was increasing and decreasing. So what do we have to do here? Derivative. We're going to have to do quotient rules. So low, d high, minus high, d low, over low squared. So we get x squared minus 4 minus 2x squared. Or x squared minus 4 squared. So that gives me a negative x squared minus 4 over x squared minus 4 squared. So then from that you need all of your critical points. This is where some of you have made some errors in the past. Critical points are where this derivative is 0 or undefined. So essentially it's where both the top and the bottom equal 0. If you set the top equal to 0, what do you get out? I's, right? So do we have to worry about that? No. So our critical points are really just when the bottom is 0. So that's when x squared minus 4 equals 0. So plus and minus 2. Okay, so then to find increasing and decreasing, we make our sign line. We are going to plug these into our derivative. So we do our test points. If you put in a negative 3, negative 3 squared is 9, so the opposite of that, negative 9 minus 14 is negative. On the bottom, we get a positive, so this whole section is negative. If you put in a 0, you get a negative 4 over 16, so that is also negative. If you put in a 3, you get a negative on top and a positive on the bottom, so that is negative. So all of those are negative. Does that mean I'm decreasing from negative infinity to positive infinity? No, because we have asymptotes at 2 and negative 2, so we do have to break our intervals up there. So it is decreasing negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. F is the maxes and mins. So looking at this, if it's always decreasing, do we have a max or min? No. Okay, G was the concavity, so we have to do our second derivative. So that's the low, D high, minus the high, D low. So the derivative of the bottom, the 2 comes down, inside stays the same, subtract 1, so that's the first, times the derivative of the inside, over the low squared. Is everybody with me? On the bottom, this would be to the 4th power. But what do you notice? Is there anything we can reduce right away? We have an x squared minus 4 here, here, and down here. So we can cancel one of those, so this would now be to the 3rd down there. Okay, so then if I distribute my negative 2x, I get negative 2x cubed plus 8x. Here, my 2 times 2 has to be 4x, so I'm going to distribute a negative 4x. So that would give me a positive 4x cubed plus 16x. Add like terms. Most of the mistakes I've been seeing on your all's work here is just skipping too many steps, trying to do too much at once. So make sure on the test you're taking the time, show your work, show what you get when you multiply those out so you don't mess up adding and subtracting like terms. Okay, so inflection points are where this is 0 or undefined. We know it's going to be undefined where? That's what makes the bottom 0. If we want to figure out what makes the top 0, what could I pull out of the top? Take out a 2x. Okay, so either 2x equals 0, or x squared plus 24 equals 0. Yes, thank you. So I pulled out a 2. If you subtract that 12 over, you get x squared equals negative 12. What's that going to be? Imaginary, so we don't have to worry about that. And over here, if you divide by 2, you get 0. So we have 3 inflection points. Negative 2, 0, and 2. So test points. Okay, if we plug these into the second derivative, so if I put in my negative 3, the top would be negative, the bottom would be positive, so that's negative. If you put in a negative 1, top is negative, the bottom would be negative, so that is positive. Put in a 1, top is positive, bottom's negative, so that's negative. And 3, positive over positive is positive. So we are concave down from negative infinity to negative 2, union 0 to 2. Concave up, -2 to 0, union 2 to infinity. Are you guys okay with all this stuff? So now if we plot everything, going back, we knew we had x and y intercepts were both at 0. We had vertical asymptotes at +2 and -2. Where was the horizontal asymptote? At 0. I will expect everything you found, I want you to draw on your graph. Okay. We didn't have any maximums or minimums on this. My inflection points happened at ± 2, but I can't get ordered pairs for those because they were asymptotes. And at 0. Let's get the ordered pair for 0. If you plug 0 into the original, you get 0. So 0, 0, we already have a point there, that's also an inflection point. Okay, we know our graph is always decreasing. Until I get to -2, it's curving downward. So if I'm decreasing, curving downward, make sure you draw it approaching your asymptotes. Okay, we have to continue decreasing. We are curved upward at first. Then once we get to this point, we are curving downward. And then from 2 to infinity, we're curved upward and decreasing. So it should look like that. Any questions there? So we went through number 1 then. Number 2 is your asymptotes. Vertical asymptotes should have been -2 and 1. Horizontal asymptote y = 0. Do we need to work out that? Let's talk about problem 3. So on problem 3, I told you the second derivative is continuous. So in other words, we don't have to worry about asymptotes here. Part A. It says f prime of 2 equals 0. If the first derivative is 0, what does that mean happens at 2? It's a critical point, or that means it's a max or a min. Okay? Then the second thing I told you is the second derivative is -5. What does that tell you? It's concave downward. So at 2 on my graph, it's either a maximum or a minimum, but the graph has to be curved downward. So if the graph is curving downward, which one would it be? Would have to be a max, wouldn't it? Because if you're curving downward, it has to be that high point. If it were a minimum, and then it would have looked like this, and that would be curving upward. So that means that 2 is a local max. Okay. Part B. It tells you the first derivative at 6 is 0. So if the first derivative is 0, that's a critical point, which means it's either a max or a min. And the second derivative is 0. If the second derivative is 0, what does that mean? Inflection point. So we're saying we could have either a maximum or minimum. And if it's an inflection point, that means my concavity is changing. You know, it could have been like curved upward and now curving downward, or vice versa. Does that tell me then whether it's a maximum or a minimum? No. So here there is no conclusion. Since I don't know that if we're curved upward or downward, I can't specify if it's a maximum or a minimum. Any questions on that? Question number 4, absolute maximums and minimums. You have to do your derivative and get your critical points, which should be -1 and 2. Do you have to test all of those? Yeah. When you do absolute max and mins, you test all of your critical points that are in the interval. So in other words, if I had gotten like a -3, would you have used it? No, because we were only looking between -2 and 3. And so then you have to test the endpoints and your critical points to get your highest and lowest. Do I need to work that one out? You should have gotten f of -1 equals 8 for the absolute max, and f of 2 equals -19 for the absolute min. So I don't need to work that. Remember, if it's not in the interval, you just don't use it. Number 5, your critical numbers, that's where your derivative is 0 or undefined, and you should get plus and minus 2 there. Do I need to work that out? 6 and 7, Rolle's theorem and mean value theorem. I'm going to ask you something about those on your test. You can expect questions about each of them, and you have to know your conditions for that to work. So the thing to keep in mind for both of those, what has to be true about your functions? Has to be continuous on the closed interval and differentiable on the open interval. If they're polynomials, you can just say it's a polynomial, so I know it's continuous and differentiable. For Rolle's theorem, it's continuous and differentiable. What else has to be true? There's a third condition. Right, the values of the endpoints have to be the same. F of A equals F of B. Then if that is all true, what does the theorem tell us? The derivative equals 0. So you can take your derivative and set it equal to 0. All right. For number 7, the mean value theorem, it has to be continuous and differentiable. Those are the only two conditions. And then it tells us that the derivative equals what? The slope between the endpoints. Okay, so 8 and 9 are when we are actually working out those theorems. Do we need to run through those maybe?
I'm good.
Does anybody want me to work on that?
I have a question. On 9, how do you know which sign, like at the very end, if it's plus and minus, how do you know which sign to do?
It has to be in the interval. So on that one, both of those fall between -2 and 2, so you keep both of them. If one of them was not in the interval, you would throw it out.
So you said equal to the slope, right?
Mm-hmm. Yeah.
Leave.
Okay. So problem 8 is Rolle's theorem. So the first thing, Rolle's theorem has 3 conditions, so you need to check your conditions. It is a polynomial, so it is continuous and differentiable. Those are the first 2 conditions. You can just tell me that. Then the next thing for the Rolle's theorem, the values of the endpoints have to be the same, so we are looking on the interval 1 to 3. So if we plug in a 1, you get -4. If you plug in a 3, you get -4. So those are equal. So Rolle's theorem applies. Then what you do for Rolle's theorem is you take your derivative. So the derivative of 5 is 0, derivative of -12x would be -12, derivative of 3x squared would be 6x. And Rolle's theorem says the derivative is 0. So if we solve this, we get x to be 2. And that is the number that makes it true. Now you should check at the end if you got multiple answers. We were looking between 1 to 3, that was the original interval. So if you had gotten like plus and minus 2, you would throw out the -2 and only use the positive. Let's run through number 9. I just think that we need to refresh that real quick. If you look at this one, it is a polynomial, so your conditions are true. It's polynomial, so continuous and differentiable. Alright, then for the mean value theorem, what do you have to do? Slope. So if you put in a -2, you get out 0. If you plug in a +2, you get out 4. So your points are -2, 0, and 2, 4. So the slope between them, y2 minus y1 over x2 minus x1. So our slope is 1. Then the mean value theorem says the derivative equals the slope. So our derivative would be 3x squared minus 3. I'm going to set that equal to 1. So 3x squared equals 4, so x squared equals 4/3. Square root with that plus and minus. Square root of 4 is 2 over radical 3, except we don't leave it like that, so you'd say plus and minus 2 radical 3 over 3. Our interval here was -2 to 2. Do both of those fall between -2 and +2? Yes, so those are the two answers.
When you're going through the requirements, so if it's a fraction, not a polynomial, continuous, you just see if anything doesn't work, like so the bottom equals 0.
Yes.
And then what would you do for difference?
You would go ahead and find the derivative and then find out where that's undefined, so where the bottom is 0. And as long as that number isn't in your interval, you're okay. Other questions? So make sure, guys, know what those theorems say. Know the conditions and know what it's telling you on both of those. It will be on your test. All right. Number 10, you had to draw a graph. Do we need to go through that? You just have to, it has to be continuous between 1 and 5, a minimum when x is 2, a maximum when x is 3, and a local min at 4. So you guys don't want me to go through that one? Number 11, let's just make sure we got those right. So your absolute max, the absolute highest point on the graph is where? F of 4 equals 5. Or you could write it as an ordered pair, 4 or 5, I don't care. The absolute min, the actual lowest point on the graph. If you look at your graph, the lowest point happens at the very end, but what's true about it? It's an open circle, so that means if it's open, there is none. You don't actually have an absolute min here. Okay, local max. So that doesn't include endpoints, you can't use those. And it's just points that are higher than those surrounding them. So if you look, like when x is 1, that would be 1, except what's wrong with it? It's open, so we can't use it. So f of 4 equals 5 would still work. And there is one more. F of 6 equals 4. Okay, because even though it's not connected, there are points on both sides, and it's higher than both of those surrounding.
So we would always put the absolute max within.
Unless it was an endpoint.
Okay.
So local mins. If you look when x is 1, you have that open circle up high, and then it's just a closed circle down low. Is that closed circle lower than the points surrounding it on both sides? Yes. So f of 1 equals 3 would be 1. When x is 2, that is lower than the points on both sides, so f of 2 equals 2. And one more, f of 5 equals 3. Again, you can't use, like at 6, you've got that open circle, but the points on the left are higher. We can't use endpoints, so those would be our only ones. questions there? Alright, number 12 was another absolute max and min question. Do we need to work that? Yeah. Your absolute, or your only critical point you should get is -2. So you have to test -5, -2, and 0. You should get f of -5 equals approximately -2.289 as the absolute min, and f of 0 equals 2 as your absolute max. Do we need to work it? Okay, let's look at it. So your derivative, exponent comes down, inside stays the same, subtract 1 from the power, so it's a -2/3. To find your critical points, it would probably be useful to rewrite this. A negative power would put that on the bottom. A 2/3, that's like saying the cube root of that square. So if you're trying to figure out where this, we had our 3 there from the 1/3, where this is 0, does the top ever equal 0? No. Critical points are also where it's undefined. What would make the bottom 0? Right, if this inside were 0, so x equals -2. So the only critical point is -2. That does fall between -5 and 0, which was our interval. So we're going to test all of those. Okay, if you plug in -5, you get -20 plus 8. So it's like the cube root of -12. Or if you gave me that as a decimal, that is -2.289. If you put in a -2, you get -8 plus 8, which is 0, so you have the cube root of 0, which is 0. If you put in a 0, 0 plus 8 is 8, so the cube root of 8 is 2. So this is our lowest, and this is our highest. Let's talk about 13. I really need to fix this one. There's actually a typo. It should say, does there exist a polynomial function? I left out a word there, which kind of makes a difference. Does there exist a polynomial function such that f of 0 equals -1? So when x is 0, you get out -1. F of 2 equals 4. And the derivative is always less than or equal to 2. Okay, so if I add in that word polynomial there, because I'm telling you it's a polynomial, we know polynomials are continuous, right? So there wouldn't be a break in our graph. If it's a polynomial, it's continuous and differentiable. So if you think about our theorems, the mean value theorem would have to work. And the mean value theorem says that somewhere the derivative equals the slope of the endpoints. So if I took my 2 points, slope is 5/2 or 2.5. This was a bonus question on one of your quizzes one time. This is saying, by the mean value theorem, the slope between the endpoints is 2.5. So the derivative equals 2.5 for some x between 0 and 2. So is it possible for the derivative to always be smaller than 2? would not be possible. Number 14 was another roles question. I gave you a function, and if you plug in your endpoints, they both give you out 0. But I'm telling you, there is not a number in the interval that makes the derivative 0. Why is that not a problem? Rolle's theorem says it has to be continuous. And this is like the cube root of x squared, so you can graph cube roots anywhere. So it is continuous. It also says it's differentiable. So to check if it's differentiable, if we do our derivative, derivative of 1 is 0, so we get negative 2/3 x to the negative 1/3. That negative power would put it on the bottom. Where is this not differentiable? The derivative isn't defined at 0. Since 0 is between negative 1 and 1, Rolle's theorem does not work. We can't use Rolle's theorem because the conditions were not true. So those two questions were really just trying to make you think about Rolle's theorem and mean value theorem a little bit more. On 15 and 16, I want to talk about, I really, really like these questions. I can promise you I will put something like this on your test because it really makes you think about your graphs and how they are related. So if I look at problem 15, it gives us this graph. I'm going to sketch it really quick. Something like this. Then part A, if you're looking at the problem, you have to be careful. Is this the graph of the original function? No. It says at the beginning, the graph of the derivative is shown. So you have to think about what this derivative tells you. Right, in part A, I want to know where the function is increasing or decreasing. If you just look at this and say it's decreasing from 0 to 2 and so forth, you're going to be wrong because this is the derivative. I want to know where the function is increasing and decreasing. So you have to think about how those are related. If the original function is increasing, what's true about the derivative? It's positive, right? So where this thing is positive will be where my function is increasing. So it has to be increasing from 0 to 1 and 3 to 5, because that's where the derivative is positive. Decreasing would be when the derivative is negative, which is from 1 to 3 and 5 to 6. Does that make sense to everyone? The second question I asked is where does it have a maximum or minimum? I didn't ask you to specify which is which, but I'm going to right here. about this in terms of your sine line. Your derivative was 0, so your critical points were at 1, 3, and 5. Okay, your derivative was positive, negative, positive, negative. So at 1, my graph went from increasing to decreasing. So what happened at 1? That's a max. At 3, it went from decreasing to increasing. So that would be a min. At 5, it went increasing to decreasing. So that would be a max. Okay, probably going to ask you something like this on the test, just to make sure you can connect all these graphs. I didn't ask this, but I'm going to now. Where would the original function have an inflection point? Okay. If you're looking at the original graph, your inflection points are where the concavity changes. If I'm looking at the derivative though, just think about it. So inflection points mean that your second derivative is 0. How can I look at the graph of my first derivative and know where the second derivative would be 0? Where it has a maximum or a minimum. So if we look, we're checking our maximums and minimums. We don't use the endpoints there. So here and here. So my inflection points would be at 2 and 4 because that's where the derivative has a maximum limit. So its derivative will equal 0 there. Okay. 16 is kind of like this, so let's run through it as well. So the graph looks something like this. We have to find the inflection points in 3 different cases, so we're going to pay close attention here. The first case is if this is the original function. So if this graph is the original, then the inflection points are where the concavity changes. Okay, if I look at this, that starts out concave down, and right here what happens? Switch to concave up, or concave up, and then concave down, and we stay concave down. So in that scenario, if this is the original, the inflection points are at 3 and 5. Okay, for B, says, okay, now this is the first derivative. If this is the first derivative, the inflection points will be where its derivative is 0. Where will the derivative of this be 0? The maxes and mins. So that would be right here, here, and here. Because the derivative at those points would be 0. Is everybody following that? The third case is, what if this is the actual second derivative? Where are the inflection points? Inflection points are where the second derivative is 0, so if this is the second derivative, it is 0 at 1, 4, and 7. Second derivative is 0 there. So you will have a question like these two on your test. Definitely, you have to look back at your mean value theorem and Rolle's theorem. Look back at this graph question. I told you there'll be 2 that you have to do everything on, 1 a polynomial and 1 a fraction. 10 total questions on the test, so I've kind of narrowed it down. I've really told you what like 5 of your questions are. So, anything that we haven't gone over that you guys want to?
Is there going to be any multiple choice?
Yes. 5 multiple choice questions.
Oh, I thought it was down a lot.
Yep. 10 total questions, 5 of them are
Oh,
multiple
it's
choice.
cute. Looked like 109. I was like, I thought she said it was just